So here we're looking at the random coin flipping data from a previous class, and what I want to know, what I want you to notice is the random sampling error that we have, and then how that starts to go away as we get a lot more data. So this is kind of where we see how important multiple replicates are. So if we take a look at this, and maybe you saw this with your own flipping the coin, but each person flipped the coin 10 times, or the pair of coins 10 times. And if we look here at Madison and Holly, basically she didn't flip any double heads. She flipped 4 head-tails and actually 6 tail-tails. We know that that is not what you would expect. We're expecting 25% to be head-head, 50% to be one head, one tail, and 25% to be tail-tail. And she didn't get that at all. This is random sampling error. It's not that Madison didn't do the flipping the coin right. You just click a button is random. But it's just that when you flip it 10 times or flip the pair of coins 10 times, you might not always get the expected values, right? And we see that in some of these other ones, all right? So here's a 1, 6, 3. We're really expecting basically a 2.5 to 5 to 2.5 ratio. And some are close to that, but hardly any of these individual times that people did this 10 times hit that 2.5 to 5 to 2.5 ratio. In fact, it would be impossible to do that because there is no way to flip double heads 2.5 times out of 10. Right? So this is random sampling error. When you do it only 10 times, you're going to get some anomalies. But when we start to add all of the data together, you see that we get pretty close to that 25% heads, 50% head-tail, and 25% tail-tail ratio. So the more replicates you have, the more you are reducing that random sampling error, and the more real your data is going to be, and the better results and the better conclusions it's going to give you. Now if I flip over to our data, you can take a look at your data as you keep adding it, but you can see here that I've already done this, and I flipped two heads 3 of the times, head tail 3 of the times, and 2 tails 4 of the times. So this is not the 25-50 to 25 ratio, but again, I would bet, if I was a gambling man, I would bet pretty high that by the time we get all of the data in here from each of you doing this, that this ratio is going to end up pretty near our 25%, 50%, 25% ratio. Right? So I have random sampling error. You may have random sampling error, but the more replicates we add in there, we hit that ratio that we would expect. The random sampling error goes down.